It hasn't rained hard enough to carve stone like this in Egypt for 7,000 years. So if a geologist stands in front of the Sphinx and says, "This was shaped by rain," one of two things is wrong. Either our understanding of erosion or our understanding of when Egypt began. Walk down into the enclosure where the figure sits, and the first thing you notice is not the monument itself, it's the walls. Vertical channels run down the limestone like water carved them over centuries. The surface is rounded, undulating, worn smooth in places and gouged deep in others. The stone looks old in a way that feels wrong for something supposedly built 4,500 years ago. It doesn't look weathered by wind. It looks weathered by water. Stand at the base of those walls and run your hand along the stone. The channels are deep enough to fit your fingers inside. They run from the top of the enclosure down to the floor, following the path rainwater would take if it fell heavily and often. The rock between the channels is rounded, softened, shaped by flow rather than abrasion. This is not the kind of erosion you see on structures exposed to desert wind. Wind cuts horizontally. Wind leaves striations, sharp edges, surfaces that look scraped rather than dissolved. This stone looks like it stood in rain for a very long time. In 1991, a geologist from Boston University examined the enclosure and concluded that the erosion pattern required prolonged exposure to rainfall, not occasional storms, not brief wet periods, sustained precipitation over centuries, possibly millennia. The kind of climate that hasn't existed on the Giza Plateau since approximately 5000 BCE. That date is not speculative. It comes from climate reconstruction, sediment analysis, and the well-documented shift from a wetter Sahara to the arid zone we see today. The rains stopped 70 centuries ago. The Sphinx, according to conventional chronology, was carved 25 centuries after that. The math doesn't work. If the monument was built during the 4th dynasty under Khafre, as Egyptologists maintain, then it was carved in an Egypt that had been dry for 2,500 years. Dry enough that no other structure from that period shows this kind of erosion. Dry enough that the tombs carved into the same plateau, some within a few hundred meters of the enclosure, show completely different weathering. Those tombs have sharp edges, horizontal striations, the signature of wind-driven sand. They look like what they are, stone exposed to 4,000 years of desert air. But the walls around the Sphinx look like they were carved in a different climate entirely. Walk from the enclosure to one of those nearby tombs, and the contrast is immediate. The tomb walls are crisp. The hieroglyphs are still legible. The limestone has been abraded, yes, but it's been abraded evenly, horizontally, in the way wind works. There are no deep vertical channels, no rounded flowing surfaces. The two structures sit on the same plateau, carved from the same limestone layer, exposed to the same 4 millennia of weather, and yet they look like they aged in different worlds. This is not a subtle difference. It's not something you need a microscope to detect. It's visible to anyone standing in both locations with a camera. The erosion on the enclosure walls is so pronounced that it doesn't just suggest water exposure, it demands it. And if the erosion demands water, then the timeline collapses. Because the water stopped before the pyramids were built, before the 4th dynasty, before the rise of the unified Egyptian state. So either the erosion is not what it appears to be, or the monument is not what we've been told. The geologist who examined the site in the early 90s was not an Egyptologist. He was a specialist in rock weathering, someone who spent his career reading stone the way archaeologists read pottery. He looked at the enclosure walls and saw a diagnostic pattern: precipitation weathering, the kind of erosion you see on limestone exposed to centuries of rainfall in a temperate or subtropical climate. He didn't arrive at Giza looking for a mystery. He arrived looking at rock, and the rock told him something that didn't fit. Egyptologists responded by pointing to the same evidence everyone else uses to date the monument: the stylistic similarities to other 4th dynasty work, the alignment with Khafre's pyramid, the absence of any earlier references in the historical record. All of that remains true. But none of it explains the stone. You can argue about who built it. You can argue about why it was built. But the erosion is not an argument. It's a physical fact. The walls are carved with deep vertical channels. Those channels require water, and the water stopped falling 70 centuries ago. So what are we looking at? If the monument was carved after the rain stopped, then something else caused the erosion, something that mimics prolonged rainfall so precisely that a geologist trained to identify weathering patterns concluded it was rain. If the monument was carved before the rain stopped, then it predates the 4th dynasty by thousands of years, and we have no record of who built it or why. Neither answer is comfortable. The first option requires explaining how wind, sand, dew, or some other mechanism could carve vertical channels into limestone in a way that looks identical to precipitation weathering. The second option requires accepting that a monument we thought we understood is older than the civilization we credit with building it. The monument everyone thinks they know may be the oldest structure on Earth still standing, and if that's true, we don't know who built it. For over a century, the answer was simple: Pharaoh Khafre, 4th dynasty, around 2500 BCE. The evidence seemed clear: stylistic, spatial, textual. The head of the monument, weathered though it is, carries the proportions and facial structure consistent with portrait statues attributed to the ruler whose pyramid stands directly behind it. That alignment is not incidental. The causeway leading to the pyramid complex runs alongside the carved pit in which the figure rests. The spatial relationship suggests a unified architectural program, a single vision executed during a single reign. This is not speculation. It is the kind of evidence archaeologists rely on when dating monuments across cultures and centuries. Then there is the Dream Stele, a granite tablet erected between the paws of the monument by Thutmose IV more than 1,000 years after the 4th dynasty. The inscription is fragmentary, but the name of Khafre appears in the damaged text, associating him with the figure carved from the bedrock. The stele does not prove construction, but it does suggest that even in the New Kingdom, tradition connected the monument to the pharaoh whose pyramid looms above it. Beyond these specific markers, there is a broader argument from capability. The 4th dynasty represents the apex of Old Kingdom stone engineering. This is the period that produced the Great Pyramid, the Pyramid of Khafre, the Pyramid of Menkaure. These are not modest structures. They are feats of organization, labor management, and precision cutting that required centralized state power, a literate bureaucracy, and a workforce numbering in the tens of thousands. The same tools, the same copper chisels and dolerite pounders, the same administrative apparatus that raised the pyramids could have carved the figure from the limestone escarpment. The technology matches the timeline, the ambition matches the dynasty. What does not match is the idea that a pre-dynastic culture, one without evidence of writing, without monumental stone architecture, without the administrative complexity required to feed and house thousands of laborers, could have undertaken such a project. Before the unification of Upper and Lower Egypt, before the rise of the pharaonic state, settlements along the Nile were agrarian, small-scale, and built primarily from mud, brick, and wood. There are no stone temples from this period, no colossal statues, no evidence of the engineering knowledge required to carve a figure 60 feet high and 240 feet long from a single outcrop of bedrock. The archaeological record does not support the existence of such capability before the Old Kingdom. This is not a weak position. It is the consensus view, built on decades of excavation, stratigraphy, and comparative analysis. It is the framework taught in every major university, defended in peer-reviewed journals, and supported by Egyptologists who have spent careers studying the material culture of the Nile Valley. The dating of the monument to the reign of Khafre is not arbitrary. It rests on the convergence of stylistic analysis, spatial context, inscriptional evidence, and technological plausibility. There is also the matter of what is absent. No pre-dynastic site in Egypt has yielded tools or techniques capable of shaping limestone on this scale. No earlier culture left behind monuments of comparable ambition. The leap from small settlements to a carved colossus without intermediate steps would represent an anomaly not just in Egyptian history, but in the broader trajectory of human civilization. Monumental architecture emerges gradually. It requires surplus, organization, and accumulated knowledge. It does not appear suddenly, fully formed, in a culture that leaves no other trace of such capacity. The argument for a fourth dynasty origin is not merely that it fits the evidence, it is that every alternative requires explaining away the absence of evidence for an earlier, more sophisticated culture. It requires positing a civilization capable of monumental stone carving that somehow left no other trace in the archaeological record. No tools, no inscriptions, no comparable structures, no administrative artifacts, no evidence of the social complexity required to organize such labor. For most of the 20th century, this was enough. The question of when the monument was built was considered settled. Debates focused on other aspects: the purpose of the figure, the symbolism of the lion body, the later restorations undertaken by successive pharaohs. But the timeline itself was not in serious dispute. This is the view taught in universities and defended in peer-reviewed literature. And then a geologist was invited to examine the enclosure walls. In 1990, Robert Schoch, a geologist from Boston University, not an Egyptologist, walked into the Sphinx enclosure at the invitation of researcher John Anthony West. He looked at the walls and said 5 words that started a war: "This monument is far older." Schoch had not come to Egypt searching for controversy. He had come to settle one. West, a writer with no academic credentials but a stubborn eye for anomaly, had been arguing for years that the body of the statue showed weathering patterns inconsistent with the climate of dynastic Egypt. He wanted a geologist to examine the claim and put it to rest. Schoch agreed to look. He expected to spend a day dismissing the idea. He spent a week documenting something he could not explain. The erosion carved into the limestone walls of the enclosure was not what wind does. Wind in a desert environment produces horizontal striations, parallel grooves carved by sand grains traveling low across the surface, abrading stone in predictable bands. What Schoch saw instead were deep vertical channels, rounded and undulating, running from the top of the enclosure walls down toward the floor. The profiles were smooth, not sharp. The weathering extended below ground level into rock that had been buried for millennia. This was not the signature of wind and sand. It was the signature of water running down stone for a very long time. He documented the depth of the channels. He measured the degree of rounding along the upper edges of the walls. He examined the subsurface weathering, the kind that occurs when water penetrates cracks and works its way into the rock over centuries. Then he walked a short distance to the tombs carved into the same Mokattam limestone during the Old Kingdom, tombs attributed to the same period as the statue itself, around 2500 BCE. Those tombs, exposed to the same wind and sand for 45 centuries, showed sharp edges and crisp hieroglyphs. The limestone faces were clean, the corners were defined, there were no vertical channels, there was no rounding, there was no deep subsurface weathering. The contrast was not subtle, it was diagnostic. Schoch returned to the enclosure and examined the body of the monument itself. The same vertical erosion patterns appeared on the limestone core, particularly along the western and southern walls, where the original bedrock had been carved away to free the figure from the plateau. The head, by comparison, showed different weathering, consistent with later repairs and recarving in a drier climate. But the body and the walls of the pit told the same story: prolonged exposure to precipitation. He knew what that implied. Egypt's climate had been arid for thousands of years. The Sahara had begun its transformation into desert around 5,000 years ago, and by the time of the Fourth Dynasty, the Nile Valley was already dry. Rainfall sufficient to carve vertical channels into limestone, rainfall heavy enough and sustained enough to produce the kind of weathering he was measuring, had not occurred in the region for at least 7 millennia. If the erosion was precipitation-induced, the monument had to predate the climate shift. It had to have been exposed during a wetter period, a period when the Sahara was still green and seasonal rains were common. That placed the carving of the statue thousands of years before the rise of dynastic Egypt, thousands of years before the pyramids, thousands of years before the civilization credited with building it existed. Schoch did not make this claim lightly. He understood the magnitude of what he was suggesting. He also understood that geology does not negotiate with archaeology. Rock records time in layers, in weathering profiles, in the physical evidence of what has touched it. You cannot argue a vertical channel into being a horizontal striation. You cannot argue subsurface, water penetration into being surface wind abrasion. The stone does not care about the timeline of pharaohs. He compared his findings to erosion patterns in other climates. He consulted the geological record of North Africa's climate history. He reviewed studies of limestone weathering under different environmental conditions. Every line of evidence pointed in the same direction. The erosion required water. The water required time. The time required a climate that had not existed in Egypt for 7,000 years. The question was no longer whether the weathering was anomalous. The question was whether the entire framework for understanding when human beings became capable of monumental construction needed to be revised. Schoch presented his findings at the 1991 annual meeting of the Geological Society of America. He later published them in peer-reviewed geology journals, not fringe publications. His conclusion was clear. The erosion visible in the enclosure is precipitation-induced, and the timeline required for that erosion is incompatible with the conventional dating of the monument to the reign of Khafre in the 4th dynasty. The response from Egyptology was immediate and hostile. Archaeologists pointed to the absence of any other evidence, no tools, no settlements, no inscriptions, that would indicate the presence of a civilization capable of such work prior to the rise of dynastic Egypt. Geologists outside the field questioned whether Schoch had adequately accounted for other weathering mechanisms. The debate became heated, personal, and entrenched, but the erosion remained. The vertical channels did not disappear. The contrast with the Old Kingdom tombs did not resolve itself, and the question Schoch had introduced could not be unasked. If the body of the monument was carved when Egypt still received rain, then who carved it? And what does that mean for the history we think we know? His conclusion was published in peer-reviewed geology journals. The erosion is precipitation-induced and requires a timeline incompatible with dynastic Egypt. 50 meters from the enclosure, past the tourist barriers and the afternoon shadow of the pyramids, sits a mastaba tomb carved during the 4th dynasty. Same plateau, same limestone, same 45 centuries of exposure to wind, sand, and sun. The hieroglyphs are still legible. Run your hand along the surface, hypothetically before the guards stop you, and you feel crisp edges where the chisel left its mark. The carvings retain depth. The stone shows wear, certainly, but it wears in a particular way. Near the base, where blown sand strikes the wall day after day, horizontal striations score the limestone in thin, parallel grooves. This is what wind does. It etches, it abrades, it carves shallow directional patterns that follow the prevailing angle of airborne particles. The damage is real, measurable, and entirely consistent with 4,500 years in one of the driest places on Earth. Now walk back to the enclosure. The walls surrounding the monument tell a different story. Deep, sinuous channels run vertically down the limestone, some of them wide enough to insert your forearm. The stone surface is not abraded, it is scoured. The edges are not sharp. They are rounded, softened, eroded into undulating contours that bear no resemblance to the crisp geometry of wind damage. These are not shallow grooves. They extend several feet into the bedrock, carving pathways that follow gravity, not the horizontal scour of sand-laden wind. This is what water does. Specifically, this is what prolonged water runoff does when rain falls on porous limestone over long spans of time. Water flows vertically. It finds weaknesses in the stone, microfractures, bedding planes, variations in density, and widens them. It dissolves calcium carbonate along the flow path, carving deeper channels with each wet season. Over centuries, those channels become gullies. Over millennia, they become the topography of the stone itself. The pattern is diagnostic. Geologists mapping erosion in humid climates recognize it immediately. Vertical runnels, rounded profiles, subsurface penetration that exceeds what surface abrasion can achieve. The limestone does not just look weathered. It looks like it stood in a climate where rain was not an occasional event, but a sustained recurring presence. And yet both structures, tomb and enclosure, are supposedly the same age. Both carved from the same Macadam Formation limestone, both exposed to the same 4.5 millennia of Egyptian sun, wind, and exceedingly rare rain. So why does one look like it was carved a few centuries ago and the other like it endured a climate that no longer exists? The question is not abstract. Stand in the enclosure at dawn, when the light rakes across the western wall and the erosion becomes a landscape in miniature. Channels fork and merge. Rounded troughs separate raised ridges of more resistant stone. The surface reads like a watershed map, every contour shaped by the behavior of flowing water. Photograph the same wall at the same angle, then photograph the mastaba tomb 50 meters away under identical lighting. Place the images side by side. The difference is not subtle. Wind erosion produces texture. Rain erosion produces topography. Wind smooths surfaces and leaves directional scoring. Rain carves depth and follows gravity. These are not interpretations. They are observable, repeatable features that any geologist working in sedimentary environments can identify without controversy. The erosion itself is not in dispute. What remains in dispute is the only variable that explains it: time under rainfall. Egypt's climate shifted approximately 7,000 years ago. The Sahara, once a region of seasonal monsoons, grasslands, and scattered lakes, entered the aridification phase that created the desert we recognize today. Rainfall did not stop overnight, but it declined steadily. By 5,000 years ago, well before the conventional date assigned to the monument, the Giza Plateau was already receiving less than an inch of rain per year, a condition that persists to the present. An inch per year does not carve vertical channels several feet deep into limestone, not in 4,000 years, not in 10,000, but several thousand years of sustained rainfall, the kind that falls during a wetter climatic phase, does exactly that. The erosion profile matches what you would expect if the structure were exposed during the African Humid Period, when the Sahara was green, and the Nile Valley received enough rain to support vegetation, runoff, and the kind of weathering now visible in the enclosure walls. Which brings the question into sharper focus. If the monument and the tomb are both 4th dynasty, both carved around 2500 BCE, why does only one of them show rain erosion? Why does the other, exposed to the same environment for the same duration, show only the expected signature of wind and sand? The conventional answer is that the monument sits lower. The enclosure is a pit, carved into the bedrock, and water pooling at the base could have accelerated erosion even in a dry climate. Occasional flash floods, groundwater wicking up through the stone, differential weathering based on the quality of the limestone itself, which varies by layer. These are reasonable mechanisms. They are not impossible, but they require the erosion to be explainable by rare episodic water exposure in a desert climate rather than sustained rainfall over millennia. They require the deep, vertically channeled, rounded erosion to have formed under conditions that produce almost no rain. And they require us to believe that a tomb 50 meters away, carved from the same stone and exposed to the same episodic floods and groundwater, somehow avoided the same weathering. If both are the same age, carved in the same stone, exposed to the same climate, why does one look like it was carved yesterday and the other like it sat in a rainforest? The Sahara wasn't always sand. 9,000 years ago, the land that would become Egypt was green. Rivers cut through grassland, herds grazed across what is now barren stone. Rain fell in sheets across the plateau where the pyramids now stand. Not occasionally, not in rare storms, seasonally, reliably, for thousands of years. This is not speculation, it is paleoclimatology, the reconstruction of ancient climate through measurable physical evidence. Ice cores from Greenland preserve oxygen isotope ratios that track moisture in the atmosphere. Lake sediments across North Africa record pollen from plants that cannot survive without regular rainfall. Marine cores drilled from the Mediterranean seabed contain dust layers that mark the precise centuries when the Sahara turned to desert and began shedding fine particles into the wind. All of these records converge on a single conclusion. The climate of Egypt was fundamentally different in the deep past, and the transition from wet to dry is not a matter of interpretation. It is written in stone, in ice, in mud. The period is called the African Humid Period. It began roughly 15,000 years before the Common Era, as the last ice age released its grip on the northern hemisphere. Orbital mechanics, the slow wobble of Earth's axis and the gradual shift in the shape of its orbit, brought the summer monsoon belt farther north than it reaches today. The result was a transformation. The Sahara bloomed. Lakes filled basins that are now dry. Rivers flowed where there is only sand. Archaeological surveys have found the remains of fishing communities hundreds of miles from the nearest water today. They were not wandering. They were settled. They lived beside lakes that no longer exist. One of those lakes covered an area larger than the Caspian Sea. Paleoclimatologists call it Lake Mega-Chad. At its peak, it spanned more than 400,000 square kilometers. Today, Lake Chad is a shallow remnant, shrinking year by year. But the ancient shorelines are still visible in satellite imagery, faint terraces etched into the landscape, marking the water levels of a lake that has been dry for millennia. The same orbital precession that filled that basin also drenched the Nile Valley. Egypt, during the African Humid Period, was not a desert, it was a savanna, and then the rain stopped. Not suddenly, not in a single catastrophic drought, but over centuries, the monsoon belt shifted southward as Earth's axial tilt continued its slow cycle. The rains that had sustained the grasslands grew less frequent. Rivers shrank, lakes evaporated. By 5,000 years before the Common Era, the climate at Giza resembled the aridity we see today. Rainfall became rare. The Sahara began its expansion. The green land turned to dust. The timeline is not vague. Sediment cores from the Nile Delta show the transition clearly. Pollen from moisture-dependent plants disappears from the record. Dust increases. The oxygen isotope signature in marine cores shifts, marking the change in atmospheric moisture. The end of the African Humid Period is not a soft boundary. It is a hard cutoff visible in multiple independent proxies. By 5000 BCE, the rain capable of carving deep vertical erosion into exposed limestone had ceased. That date is the boundary condition. If the erosion on the body of the monument in the pit at Giza was caused by rainfall, if the weathering pattern carved into its enclosure walls and its flanks is the result of water running down stone for centuries or millennia, then the carving had to occur before the rain stopped, not during a brief wet interval, not during occasional storms in a dry climate, during the sustained seasonal rainfall of the African Humid Period. Because the kind of erosion described in earlier sections does not form in decades, it forms over long stretches of time, under consistent climatic conditions. The orthodox chronology places the carving of the monument during the reign of Khafre, around 2500 BCE. That is well within the historical period. Hieroglyphic records exist. Dynasties are documented. The pyramids beside the figure in the pit are attributed to named rulers whose reigns are cross-referenced in multiple sources. There is no ambiguity in the historical record about when Egypt's monumental construction began. It began after the rain stopped. But if the erosion requires millennia of rainfall, and the rainfall ended 7,000 years ago, then the monument had to be standing before 5000 BCE. That is 2,500 years before the conventional date, 2,500 years before the 4th dynasty, 2,500 years before the pyramids, before hieroglyphs, before the unification of Upper and Lower Egypt, before any civilization recognized by orthodox archaeology existed in the Nile Valley. The climatological record does not bend. The orbital mechanics that drove the monsoon northward and then pulled it away are calculable, predictable, and confirmed across dozens of independent data sets. The rain that carved the land stopped when it stopped. If the erosion on the monument is rain erosion, then the monument was there when the rain was there. That is the boundary condition. That is the temporal wall. The climate does not care about dynastic chronology. It does not negotiate with the historical record. It simply marks the point in time when the weather capable of producing the observed erosion ceased to exist in that region. The stone says rain. The climate record says the rain ended 7,000 years ago. The Egyptian record says the monument was carved 4,500 years ago. All three cannot be correct. Weathering doesn't just sit on the surface, it infiltrates. And when you dig beneath the floor of the monument's enclosure, you find something that shouldn't be there. Erosion channels carved into bedrock that has been buried under sediment for millennia. The visible grooves on the body of the monument are dramatic, but they tell only half the story. The other half is underground. Geologists examining the site have documented vertical fissures extending more than 3 feet below the current ground level of the enclosure. These are not cracks from structural stress. They are weathering channels carved by water moving downward through permeable stone, widening natural joints in the bedrock over extended periods of exposure to rainfall. The critical detail is this: these subsurface channels are filled with sediment. That means they were carved first, then buried, then, much later, partially excavated again when the enclosure was cleared in antiquity and again in modern times. The sequence matters. If the monument was carved in 2500 BCE and remained exposed, the subsurface weathering should not exist at all. Bedrock beneath the floor of the enclosure should show no deep erosion, because it would have been protected by overlying sediment or pavement from the moment the site was constructed. But the erosion is there. Deep, stratified, filled with layers of fine silt that indicate prolonged burial after the weathering occurred. This is not a surface phenomenon. It is a stratigraphic record. Stratigraphy is the study of rock layers and the order in which they were deposited. It is one of the most reliable tools in geology because it records time in physical sequence. What lies beneath must be older than what lies above. And in the enclosure, what lies beneath is weathered bedrock, weathered before it was buried. Surveys of the enclosure floor reveal that the limestone at the base of the monument shows the same undulating scalloped erosion as the walls. In some areas, the bedrock dips and rises in smooth, wave-like forms, consistent with prolonged surface runoff and pooling water. These features are not the result of a few decades of rain. They represent sustained hydrological weathering over centuries, possibly millennia, and then the weathering stopped. Not because the rain stopped, though it did, but because the site was buried. Core samples taken from sediment layers within and around the enclosure show fine laminations of silt and clay, the kind deposited by slow, gradual accumulation in a low-energy environment. No sudden flood, no catastrophic burial, just time and the steady settling of dust and wind-blown material over a landscape no longer subject to heavy rain. The sediment itself can be read, Thin, horizontal layers suggest deposition during arid conditions. Thicker, more chaotic layers, found deeper in the sequence, suggest wetter periods. The transition is visible in the stratigraphy: wet climate, dry climate, burial, and much later, excavation. But if the monument was carved during the 4th dynasty, around 2500 BCE, Egypt was already dry. The African Humid Period had ended thousands of years earlier. The Sahara had already expanded. The Nile had long since settled into its current regime. There should be no thick layers of wet period sediment overlying a monument built in the middle of the desert's driest phase. And yet the sediment is there, stratified, datable by the pollen and organic fragments it contains. And beneath it, carved into stone that was weathered before the sediment arrived, is the monument. One explanation is that the visible structure was built in 2500 BCE, but the enclosure itself, the pit from which the stone was quarried, was cut far earlier, weathered over millennia, buried, and then re-excavated by the 4th dynasty builders who carved the figure we see today. That would explain the subsurface erosion without requiring a pre-dynastic construction date for the monument itself. But it raises another question. Why would 4th dynasty engineers excavate a pit that had already been weathered and filled? Why not quarry fresh stone? And if they did re-excavate an older site, why is there no record of it? No inscriptions, no references, no acknowledgement that they were working in a location that had been carved, abandoned, and buried long before they arrived. The alternative is that the monument, not just the enclosure, predates the 4th dynasty, that it was carved during a wetter climate, weathered over thousands of years, partially buried as the climate dried, and then cleared and possibly recarved during the dynastic period. That would explain the subsurface erosion, the sediment layers, and the depth of the weathering channels beneath the current ground level. But it would also mean the monument is older than the pyramids, older than the oldest known large-scale stone construction in Egypt, older than the civilization traditionally credited with building it. Geologists studying the site have mapped the subsurface weathering in detail. The channels extend not only beneath the floor of the enclosure but also laterally into the bedrock walls, in patterns that suggest prolonged water infiltration from above. Rainwater seeping down through joints in the limestone, dissolving calcium carbonate, widening fissures, carving grooves that would later be filled with sediment as the climate shifted and the rains ceased. The depth of this infiltration is measurable. In some locations, weathering extends more than 4 feet below the current surface. That is not the result of a few wet decades. It is the result of sustained exposure to a climate that no longer exists in this region, and it is not limited to the enclosure. Similar subsurface weathering has been documented in the bedrock surrounding the monument, in areas that were never part of the structure itself, but were exposed to the same climatic conditions. The weathering is regional, not localized. It reflects a period when the entire plateau was subject to rainfall intense enough to carve stone several feet below the surface. That period ended, according to climate data, around 5000 BCE, possibly earlier in some areas. By 2500 BCE, the Sahara was already a desert. The rain was gone. The weathering should have stopped millennia before the 4th dynasty, but the monument stands in the middle of it, carved from stone that was weathered before it was buried, surrounded by sediment that records the transition from wet to dry. And beneath it, channels carved by water that has not fallen in Egypt for 7,000 years. If the figure was carved in 2500 BCE and remained mostly exposed, subsurface weathering this deep should not exist, unless it was already ancient when the pyramids were built. Egyptologists and many geologists offer a simpler explanation. The weathering isn't from rain at all. It's from salt, groundwater, and the natural variability of limestone itself. This is not a dismissal. It is a mechanism documented in deserts worldwide, and it deserves to be examined at full strength before we decide whether it explains what stands in the enclosure. The process is called haloclasty. Groundwater beneath the plateau contains dissolved salts. As moisture wicks upward through porous limestone, it evaporates at the surface. The salt crystallizes. Crystals grow inside the stone's pores, exerting pressure from within. The surface flakes, the stone rounds. Over centuries, this produces erosion that can mimic the appearance of water damage without a single drop of rain falling from the sky. The mechanism is real. It operates today in monuments across Egypt. Tombs at Saqqara show flaking and surface loss consistent with salt weathering. Temples in Upper Egypt exhibit similar decay. The phenomenon is not speculative. It is measurable, repeatable, and visually identical in certain cases to what rain can produce on softer stone. Now add a second factor: differential lithology. The Mokattam Formation limestone from which the monument was carved is not uniform. It was deposited in layers over millions of years, and those layers vary in hardness, density, and resistance to erosion. Softer strata erode faster than harder ones. Even under perfectly uniform weathering conditions, wind, salt, moisture, the surface becomes undulating. Horizontal bands of harder stone protrude, softer bands recede. The result is a rolling, wave-like texture that can appear from a distance like the work of flowing water. This too is documented. Geologists working in arid climates have catalogued this effect in sedimentary rock across North Africa and the Arabian Peninsula. It does not require rain. It requires only time, variation in the stone, and exposure to the elements. Then there is wind. The western desert delivers sand-laden gusts across the plateau with enough force to abrade exposed stone. Wind erosion is directional. It undercuts monuments at ground level, where airborne particles strike hardest. The lower portions of the figure show exactly this kind of wear: horizontal striations, undercutting at the base, and loss of detail where the body meets the floor of the enclosure. All three processes, salt crystallization, differential hardness, and wind abrasion, are present at Giza. All three produce erosion, and all three operate without requiring a single millennium of rainfall. So why should we doubt the conventional timeline at all? Because the question is not whether these processes exist. The question is whether they account for the specific morphology carved into the walls of the enclosure. Haloclasty produces surface flaking and rounding. It does not carve deep vertical channels that run from the top of an 8-meter wall to the floor. Salt weathering weakens stone from within, but it does not organize erosion into parallel grooves aligned with gravity. The pattern it leaves is pitted, crumbled, and diffuse, not channeled. Differential lithology explains undulating surfaces. It does not explain why those undulations are vertical rather than horizontal. If the erosion were driven purely by variation in hardness, the pattern should follow the bedding. Planes of the limestone, which run horizontally through the formation. What we see instead are features that cut across those planes, top to bottom, as though something flowed downward over the surface for a very long time. Wind abrasion is directional, but its direction is horizontal. It carves striations parallel to the ground. It undercuts. It does not gouge vertically, and it does not penetrate deeply into stones sheltered within a pit. The walls of the enclosure are recessed. They sit below the level of the surrounding plateau. Wind does not pour downward into a depression and carve the walls from top to bottom. It skims across the surface and strikes what protrudes, so the orthodox mechanisms are real. But their signatures do not match, and there is a control. Just a few hundred meters away, tombs of the 4th dynasty, carved from the same Mokattam limestone, exposed to the same groundwater, the same salt, the same wind, show none of this. Their walls are sharper, their surfaces are flatter. They exhibit the expected wear of 4.5 millennia in the desert: surface pitting, some loss of detail, horizontal striations where sand has scoured the lower edges, but no deep vertical furrowing, no rolling water-worn contours, no channels. If haloclasty and differential lithology were sufficient to explain the enclosure, they should have produced the same effect on stone of the same age, in the same environment, under the same conditions. They did not. That does not prove the monument is older, but it does mean the standard explanation is incomplete. Something additional happened to the stone in the enclosure, something that did not happen or did not happen to the same degree to the stone around it. What could that be? One possibility is that the enclosure was excavated earlier and thus exposed longer. If the pit was carved thousands of years before the Fourth Dynasty, the walls would have experienced millennia of weathering that the tombs did not. But that returns us to the question we are trying to avoid. If the pit is older, who carved it? And why does it show a weathering profile consistent with sustained precipitation? Another possibility is that the stone in the enclosure was uniquely soft, or uniquely saturated, or uniquely positioned to channel groundwater in a way that mimicked rainfall. But surveys of the formation show no such anomaly. The limestone varies, but not enough to explain why one pit looks like it was shaped by a river, while structures a few hundred meters away look like they were shaped by wind. These processes are real, documented, and observable. But do they fully account for deep vertical channels that run from top to bottom of 8-meter walls? Salt weathering is real, but it has physical limits, and the erosion on the monument exceeds them. Haloclasty is the technical term for what happens when groundwater carrying dissolved salts rises through porous stone, reaches the surface, and evaporates. The water leaves. The salt remains. It crystallizes inside the pores of the rock, expanding as it forms, and the stone fractures from within. The surface flakes, crumbles, becomes friable. Over centuries, the damage accumulates. The process is well documented in coastal structures, desert monuments, and buildings built on saline soils. No one disputes that it happens. The question is whether it can explain what we see carved into the walls of the enclosure. The mechanism depends on capillary action. Groundwater does not simply sit at the water table. It wicks upward through the microscopic pores in limestone, drawn by surface tension, climbing against gravity in narrow channels the way ink climbs a paper towel. In Mokattam limestone, the material from which the plateau is carved, capillary rise typically reaches 2 to 3 meters above the water table under optimal conditions. That is the height at which groundwater can deliver salt to the surface. Above that elevation, the force weakens. The water cannot climb higher. The salt cannot reach. The weathering stops. Now measure the enclosure walls. The erosion does not stop at 2 meters. It does not stop at 3. The undulating, deeply weathered surface extends 8 to 10 meters above the floor of the pit. That is not a small discrepancy. It is not a marginal overshoot. It is 3 times the maximum height that capillary action can sustain in this stone. If haloclasty were the dominant mechanism, the damage should be concentrated near the base, fading rapidly with elevation. Instead, the weathering is severe and continuous across the entire vertical face. The distribution is wrong. There is a second problem. Salt weathering is diffuse. It does not carve channels, it does not create linear grooves, it produces surface scaling, granular disintegration, and honeycomb textures where the stone crumbles in patches. What it does not produce is the kind of vertical, parallel, water-carved runnels that appear on the enclosure walls. Those features are diagnostic of flowing water. They form when rainwater runs down a surface, concentrating in depressions, deepening them over time, carving distinct pathways. The morphology is not consistent with salt crystallization. It is consistent with runoff. Consider the orientation. The heaviest erosion is not uniform around the monument. It is concentrated on the western and southern walls of the enclosure, the surfaces that would have faced the prevailing wind and rain during the African Humid Period. If groundwater and salt were the primary agents, the damage should be relatively uniform at any given elevation, determined by proximity to the water table and the porosity of the stone. Instead, the pattern follows the geometry of weather exposure. The distribution matches what you would expect from precipitation, not from subsurface moisture. There is also the question of the water table itself. The level has fluctuated over millennia, rising and falling with changes in the Nile and seasonal variation. But even during periods of higher groundwater, the capillary zone would remain bounded by the same physical limits. The height of capillary rise is a function of pore size and surface tension, not the absolute elevation of the water table. Raising the table raises the zone of salt weathering, but it does not extend it upward beyond the 2 to 3 meter range. The erosion we observe is still too high. Some have argued that ancient flooding could have raised water levels inside the enclosure, soaking the walls and allowing salt to penetrate higher. But flooding leaves its own signature. It produces horizontal banding, sediment lines, and differential weathering at the high water mark. None of that is present. The erosion is vertical, not horizontal. It follows the path of descending water, not standing water. The pattern is wrong for inundation. Wind abrasion has also been proposed as a contributing factor. The desert is not short of wind, and wind-driven sand can erode stone over time. But wind erosion produces horizontal striations, smoothing, and undercutting near the base where saltating sand grains concentrate their energy. It does not carve vertical channels. It does not produce the deeply furrowed, rolling topography that characterizes the enclosure walls. The texture is wrong. The orientation is wrong, the depth is wrong. What remains is the simplest explanation, the one that fits the morphology, the elevation, the orientation, and the depth. Rain. Not occasional rain, not brief storms, but sustained, heavy, seasonal rainfall over thousands of years, the kind of rainfall that carved valleys, fed lakes, and supported grasslands across the Sahara during the African Humid Period, the kind of rainfall that ended 7,000 years ago. The Haloclasty rebuttal does not fail because the process is imaginary. It fails because the physics cannot reach high enough, the morphology cannot match the features, and the distribution cannot explain the pattern. Salt weathering is real, it is simply insufficient. The morphology is wrong for salt, the elevation is wrong for groundwater, the orientation is wrong for wind. What is left is rain, the proportions are wrong. Stand far enough back from the monument and the mismatch becomes undeniable. The head sits too small for the body beneath it, not subtly undersized, not a stylistic flourish, measurably, architecturally wrong. The ratio of cranium to torso falls outside the range of every other colossal statue Egypt ever produced. The Old Kingdom sculptors worked within strict canons of proportion. Seated figures, standing figures, recumbent lions, all followed geometric rules refined across centuries. The figure in the Giza enclosure does not. If you compare the leonine body to the human head, the skull appears almost compressed, as though the carver ran out of stone before finishing the face. The neck is too short. The transition from jaw to chest feels abrupt. The head, relative to the mass of the haunches and forelimbs, belongs to a different scale entirely. Egyptologists have noted this for decades, usually attributing it to erosion or the irregularities of the bedrock. But erosion does not selectively shrink one part of a statue, and bedrock does not dictate proportion. The sculptor does. So why would the artisans of the Fourth Dynasty, masters of monumental symmetry, carve a figure so visibly unbalanced? One possibility: they did not carve the whole thing. The recarving hypothesis begins with a simple observation. If the head you see today was carved from a larger, already weathered form, the proportional mismatch resolves itself. The body remains ancient, the head becomes dynastic. And the contradiction between the stylistic resemblance to Khafre and the geological age of the body dissolves, because both are true. Imagine the monument as it may have stood thousands of years before the pyramids. A lion, perhaps, fully leonine, head and body in proportion, carved or shaped from the limestone bedrock during an earlier epoch, then left to weather under rains that carved deep into the stone. Millennia pass. The climate shifts. The Sahara expands. By the time Khafre's engineers arrive at Giza, the figure is already ancient, its features worn, its original identity obscured by centuries of water erosion. The pharaoh's sculptors do not build it, they find it, and they recarve the head. This is not speculation for its own sake, it is a hypothesis with explanatory power. If the original head was a lion, larger in proportion to the body, and the dynastic sculptors reduced it to a human face, the size discrepancy makes sense. Recarving always reduces mass. You cannot add stone, you can only subtract. A larger leonine head, carved down to a smaller human one, would leave exactly the proportional imbalance we observe. It would also explain the stylistic match to Khafre. The face does resemble 4th dynasty royal portraiture. The features align with the conventions of the period. But that does not mean the entire monument dates to that period. It means the head does. If the sculptors of Khafre's reign recarve the face, they would naturally render it in the style of their time, in the image of their king. The geology of the body and the artistry of the head no longer conflict. They describe two different moments in the monument's history. Look again at the neck. The junction between head and body shows signs of reworking. The stone here is smoother, less eroded, more consistent with later dynastic carving. The head itself lacks the deep vertical fissures that score the torso and flanks. If the entire figure had been carved at once and weathered together, the erosion should be uniform. It is not. The head appears younger than the body, not because it escaped the rain, but because it was carved after the rain had stopped. There is another detail. The head, as it exists now, fits tightly within the remaining block of stone. There is almost no excess material around the crown or the sides of the face. If this had been the original design, carved in one phase, you would expect more generous proportions, more stone left around the head to match the mass of the body. Instead, the head looks constrained, as though the sculptor was working within the limits of what remained after the original form had already eroded. Recarving also explains why no other monument at Giza shows comparable water erosion. If the body of the statue predates the 4th dynasty by thousands of years, it would have been exposed to a climate the pyramids never experienced. The pyramids were built in the arid conditions that persist today. The leonine body, if older, would have weathered under rain. By the time the dynastic period arrived, the rains had long since ceased. Khafre's engineers carved the head in a desert. The body had been shaped in a different world. This hypothesis does not require a lost civilization. It does not demand advanced technology or forgotten empires. It requires only that something was carved earlier than we assume, weathered naturally, and later modified. Cultures throughout history have repurposed older monuments. Roman emperors recarved the faces of their predecessors. Medieval builders cannibalized ancient temples. The practice is common. What makes this case unusual is the implication. If the body is pre-dynastic by millennia, it pushes monumental stone carving back into a period we have no other record of. And that is where the hypothesis becomes difficult to ignore, because it does not ask you to dismiss the geology. It accepts the erosion as real. It does not ask you to dismiss the stylistic evidence. It accepts the face as 4th dynasty. It reconciles both by proposing that the monument has two ages, one for the body, one for the head. The question is no longer whether the geology or the art history is wrong. The question is whether we're looking at one creation or two. If the head was recarved, then the figure you see today is a composite. Ancient body, dynastic face. A monument that spans epochs, revised by a civilization that inherited it rather than built it. And if that is true, the timeline does not collapse, it deepens. The 4th dynasty did not carve the statue. They claimed it, but claiming it required altering it, and altering it required reducing the head. And reducing the head left a proportion that does not match. The mismatch is not a flaw. It is a signature. a record of two moments in time separated by thousands of years, compressed into a single form. The hypothesis allows the monument to be both old and dynastic, the body carved in deep time, the face carved in history, and the erosion, the style, the proportions, all of it explained without invoking catastrophe or conspiracy. But if the head was recarved, what did the original look like? And more importantly, who carved it the first time? The monument was not built. It was revealed, carved downward into bedrock by removing everything around it. The workers did not raise stone. They lowered the desert floor, cutting deeper and deeper into the plateau until a figure emerged from what remained. And the limestone they removed did not disappear. It is still there, stacked in massive blocks around the perimeter of the pit, forming two temples that may be thousands of years younger than the statue they flank. This is the construction sequence no one disputes. The enclosure is a quarry. The temples are made from the quarry's stone. The question is not whether this happened. The question is when. Stand at the base of the pit and the geology becomes architecture. The walls are not smooth. They are stratified, carved through horizontal bands of limestone laid down over millions of years. Some layers are dense and hard, others are soft, crumbling under a fingernail. The statue itself reflects this variation. The head, carved from the uppermost layer, is relatively intact. The body, cut from softer strata below, is deeply scoured. The weathering follows the stone, not the shape. That tells you the erosion respected geology, not design. Now look at the temples. The Valley Temple sits just east of the enclosure. The structure attributed to Khafre is built from blocks that weigh up to 200 tons. Some are more than 20 feet long. They are not small stones mortared together. They are monoliths, fitted with almost no gap between them, and they were quarried directly from the trench. Geologists have matched the limestone in the temple walls to specific layers in the enclosure. The correspondence is exact. The blocks came from the pit. That much is certain. But here is where the sequence begins to fracture. The temple blocks show no vertical erosion, no deep channels, no scalloping. The surfaces are weathered, yes, but the wear is shallow, consistent with wind and sand over a few thousand years. The enclosure walls, by contrast, are carved into waves. If both were exposed to the same conditions for the same duration, they should look the same. They do not. One explanation is that the temples were built later, much later, that the enclosure was already ancient when the blocks were cut and stacked, that workers in the age of the pyramids looked into a pit containing a weathered statue no one could date and decided to build around it, using stone from the trench itself. In this reading, the temples are not contemporary with the carving. They are a response to it, a frame built around something already there. This is not a fringe interpretation. It is a logical inference from the physical evidence. If the statue was carved and the temples built in a single event, the stone should age uniformly. It does not. The enclosure looks older, not by decades, by millennia. Consider what that implies. The limestone blocks used in the temples were cut from walls that had already been exposed to weathering. If those walls had been carved and immediately quarried, the stone would have been fresh. But if the pit had sat open for thousands of years, eroding under rain, then the blocks extracted later would carry no record of that erosion. They would have been taken from deeper, protected layers or from sections less exposed. The temples, built from freshly cut stone, would begin their weathering clock at zero. The enclosure, already ancient, would continue from where it left off. Walk the perimeter and the sequence becomes visible. The massive core blocks of the Valley Temple are not decorated. They are functional, structural, older in style than the granite casing added later. Some researchers interpret this as evidence of two construction phases. The core temple, built from enclosure stone around an already weathered monument. The granite veneer, added centuries later during the 4th dynasty, when Khafre claimed or renovated the site. In this view, Khafre did not build the statue, he inherited it. He may have recarved the head. He certainly built around it, but the figure in the pit was already there. Now reverse the sequence. Imagine the site 7,000 years ago, when the rain still fell. The plateau is being carved. Workers are cutting down through limestone, exposing layer after layer until a lion-bodied figure remains. The trench is open to the sky. Rain falls. Year after year, century after century, water runs down the walls, carving channels, deepening fissures, scalloping the softer layers. The statue weathers, the pit weathers, then the climate shifts. The rain stops, the desert expands. The site is abandoned or forgotten or simply left alone. Millennia pass. The fourth dynasty rises. Engineers arrive at Giza. They find a weathered statue in a trench. They do not know who carved it. They may not care. What they see is a quarry, already opened, filled with usable stone. They cut blocks from the walls. They build temples. They add a granite face to the valley temple. They may recarve the statue's head to resemble their king. They claim the site, but they did not create it. This is reverse archaeology. You do not start with the artifact and work backward. You start with the stone and read forward. The enclosure is older than the temples. The temples are built from the enclosure. The weathering is not uniform. Those three facts alone suggest a sequence that does not fit a single construction event in the middle of the third millennium. But there is a problem. If the temples were built later, using stone from around an already ancient statue, then the original carvers possessed the skill to excavate the trench and shape the figure, but left no other trace. No tools, no inscriptions, no contemporary structures, just the statue, alone in a pit, waiting for a civilization that had not yet arrived. The stones tell a sequence. First, the monument was carved, then it weathered. Then the temples were built from the leftover stone. That sequence does not fit a single construction event in 2500 BCE. If the monument in question predates agriculture, it would be unprecedented in Egypt, but not in the world. In the hills of southeastern Turkey, 9 miles from the Syrian border, archaeologists uncovered something that should not exist according to the old models of civilization. The site is called Göbekli Tepe. It consists of massive stone circles built from T-shaped pillars, some weighing more than 10 tons, carved with detailed reliefs of animals: scorpions, foxes, vultures, serpents. The pillars stand in deliberate arrangements. The carvings are not crude, and the people who built it had no agriculture, no cities, no metal tools, and no written language. The radiocarbon dates are unambiguous. The oldest layers at the site go back to approximately 9,500 BCE. That places the construction more than 6,000 years before Stonehenge and more than 7,000 years before the first Egyptian pyramid. The people who erected these stones were hunter-gatherers. They lived in a world without wheat fields, without pottery, without permanent settlements. They hunted wild game and gathered wild grains, and in their spare time, they organized the labor to quarry, carve, transport, and erect multi-ton limestone pillars in geometric arrays. This was not supposed to be possible. The textbook model of civilization assumed a clear sequence: first agriculture, then surplus food, then specialization of labor, then monumental architecture. The monuments were supposed to come last as the crowning achievement of settled societies with enough resources to support non-productive workers. Göbekli Tepe reversed that order. The monument came first. Agriculture came later. The site was already ancient and buried by the time farming began in the region. The implications are not abstract. If pre-agricultural societies could organize the labor to build stone temples, then the capacity for monumental construction does not require pharaohs, scribes, or state-level bureaucracy. It requires only coordination, motivation, and time, and that opens a door that was previously closed. The example is not isolated. In what is now Louisiana, a site called Poverty Point reveals another form of monumental construction by people who lived outside the urban model. The site consists of massive concentric earthwork ridges arranged in a geometric pattern more than 3/4 of a mile across. The people who built it had no cities, no writing, and no centralized state. They were hunter-gatherers and fishers who lived along the Mississippi River floodplain. The earthworks date to around 1700 BCE, and the labor required to move millions of cubic feet of soil by hand suggests an organizational capacity that does not fit the old assumptions about pre-urban societies. These sites do not prove that the monument beside the pyramids is older than dynastic Egypt. But they do something more important. They eliminate the argument that such a thing would be impossible. For decades, one of the primary objections to an older date for the carved figure in the enclosure was that no pre-dynastic culture in Egypt had the capability to produce monumental stone sculpture. The logic was straightforward. If there is no evidence of large-scale stoneworking before the pharaohs, then the monument must belong to the pharaonic period. The alternative required imagining a lost civilization with skills that appeared suddenly, left one statue, and then vanished without a trace. But the discovery of the Turkish site dismantled that objection. It demonstrated that monumental stonework does not require cities or kings. It can emerge from societies that leave almost no other trace in the archaeological record. The pillars at the site were carved, erected, and then deliberately buried. For millennia, the site was invisible. If it had not been excavated, we would have no idea it existed. That raises a different question. How many other monuments were built, used, and buried before the rise of the first kingdoms? The carved figure in the pit is not portable. It is not a tablet or a tool that might survive in a tomb or a midden. It is a massive limestone sculpture locked in place by its own weight. If it predates the pyramids by thousands of years, it would not necessarily leave behind a supporting cast of artifacts. The people who carved it might have lived in temporary camps, used organic tools that decayed, and left no written record. The statue itself would be the only evidence. And that is exactly what makes the question so difficult to resolve. The monument is either the first thing the Egyptians built in stone, or the last thing an earlier people left behind. Both scenarios are archaeologically plausible. The difference lies in the erosion. What the Turkish site proves is not that the monument is old. It proves that the capacity to carve stone and move stone and organize labor around stone existed long before the first pharaohs. The question is no longer whether pre-agricultural people could do it. The question is whether they did it in Egypt, and whether the carved figure in the enclosure is the only thing that survived. Because if it is not the only thing, then the implications extend beyond one statue. If a pre-dynastic culture in Egypt had the ability to carve limestone on that scale, then other monuments might carry the same hidden age. And the timeline we use to anchor the rise of civilization might be resting on a foundation that is younger than the stones beneath it. If the monument truly predates the pharaohs by 5,000 years, then someone built it. Someone quarried the stone. Someone carved the paws, someone shaped the head, and that someone left behind almost nothing else. No cities, no pottery workshops, no tool caches, no tombs filled with the bones of workers, no administrative records, no temples, no evidence of the organizational complexity required to move and carve hundreds of tons of limestone with precision. The geological argument points to a date around 9000 BCE. The archaeological record from that period points to something closer to scattered hunter-gatherers along the Nile, living in temporary shelters, making simple stone tools, and leaving behind no trace of monumental ambition. This is the void at the center of the early date hypothesis. It is not a gap that can be waved away. It is the single strongest argument against revising the timeline, and it deserves to be confronted directly. The pre-dynastic cultures of Egypt are well documented. The Badarian culture, emerging around 4400 BCE, produced pottery, copper tools, and early agricultural settlements. The Naqada cultures that followed show increasing sophistication, painted ceramics, trade networks, early metallurgy, the beginnings of social stratification. By 3500 BCE, the archaeological record shows the clear trajectory toward state formation. By 3100 BCE, the unification of Upper and Lower Egypt. By 2600 BCE, the construction of the step pyramid at Saqqara, the first large-scale stone monument in Egypt, and even that required decades of experimentation with mud brick mastabas before the leap to stone. Nowhere in this progression is there evidence of monumental stone carving before the Third Dynasty. Nowhere is there a culture capable of planning, organizing, and executing a project the size of the figure at Giza. The timeline is continuous. The development is gradual. The archaeological sequence is internally consistent. And then the erosion hypothesis asks us to believe that 5,000 years earlier, during a period when the Sahara was still green and the Nile flowed through a landscape of savanna and seasonal lakes, a culture existed that could carve a statue 20 meters, tall and 70 meters long, align it to the equinox, and then vanish so completely that it left behind no cities, no writing, no pottery, no metallurgy, no graves, and no descendants who remembered building it. How is that possible? The question is not rhetorical. It is the central problem. If the weathering on the enclosure walls truly requires thousands of years of rainfall, and if that rainfall ended around 7,000 years ago, then the monument must be older than the civilization that surrounds it. But if it is older, where is the culture that built it? One answer is that we have not found it yet. The African Humid Period, which lasted from roughly 11,000 to 5,000 years ago, transformed the Sahara into a fertile landscape dotted with lakes and rivers. Populations expanded into regions that are now desert. When the climate shifted and the rains failed, those populations either migrated or collapsed. The archaeological sites they left behind are now buried under sand, submerged beneath rising water tables, or eroded beyond recognition. The Nile itself has moved, the delta has advanced, sediment layers have accumulated. What was once on the surface is now meters below it. But this is an argument from absence. It is not evidence. It is a possibility, not a proof. And the longer the absence persists, the harder it becomes to sustain the hypothesis. Consider what would be required. A society capable of quarrying, transporting, and carving limestone on this scale would need a labor force in the thousands. It would need food surpluses to support non-agricultural workers. It would need administrative systems to organize the effort. It would need tools, workshops, housing, water supply, waste management. It would need a reason to build something this large and this permanent, and all of that infrastructure, all of those people, all of that activity would leave traces. Stone tools scatter, pottery sherds accumulate, hearths leave charcoal, graves preserve bone, settlements leave post holes, storage pits, middens, even temporary camps leave lithic debris. The archaeological record is not fragile. It is remarkably persistent, and for a project of this magnitude sustained over years or decades, the absence of any supporting evidence is not a minor gap. It is a canyon. The orthodox position does not ignore this, it leans into it. The reason there is no evidence of a pre-dynastic monument-building culture, the argument goes, is that no such culture existed. The weathering patterns can be explained by localized water flow, by wind, by the differential hardness of the limestone beds, by post-construction flooding, by any number of mechanisms that do not require pushing the date back 7,000 years. The archaeological silence is not a mystery, it is confirmation. The monument was built when the evidence says it was built during the Fourth Dynasty by the civilization that left behind pyramids, temples, tombs, tools, and texts, and yet the weathering remains. The vertical channels remain. The depth of the erosion remains. The comparison to the tombs carved a few hundred meters away remains. The geological evidence does not dissolve simply because the archaeological record is empty. So we are left with a choice. Either the geological interpretation is wrong and the erosion can be explained without requiring millennia of rainfall, or the archaeological interpretation is incomplete and the absence of evidence reflects the limits of what we have searched for, where we have searched, and what survives. But absence of evidence is not evidence of absence, especially for a culture that may have existed during the African Humid Period and vanished when the climate collapsed. What if the monument was never built all at once? Not a single project under a single ruler, but a sequence of interventions separated by millennia, one culture carving, another abandoning, a third discovering, a fourth restoring. The erosion would then be ancient. The inscriptions would be genuine. The geology would be rain. The archaeology would be dynastic, and the contradiction would dissolve. This is the timeline that accommodates both sides. Begin 9,000 years before the present. The Sahara is not yet desert. The African Humid Period has turned the region into grassland, dotted with seasonal lakes and crossed by rivers that no longer exist. Rainfall in what will become Egypt averages 10 times its modern level. The Nile Valley is wetter, greener, and inhabited by cultures whose names we do not know because they left no written record. On the limestone plateau west of the river, someone carves a large figure from the bedrock. The body is leonine. The head originally may have been as well. The figure faces east. It sits in a trench carved into the plateau, surrounded on three sides by vertical walls of stone. For 3,000 years it rains. Water pools in the enclosure after every storm. It runs down the walls in vertical channels, carving deep into the softer layers of limestone and leaving the harder strata standing in relief. The figure weathers. The walls erode. The floor of the pit becomes uneven as water dissolves the stone differentially. The monument is not maintained. Perhaps the culture that carved it has moved on. Perhaps it has collapsed. Perhaps the figure was never meant to be permanent. But the rain continues and the erosion deepens. Around 5,000 years before the present, the climate shifts. The monsoon belt that fed the Sahara retreats southward. Rainfall declines, lakes dry, rivers shrink, the grasslands turn to scrub, then sand. Within a few centuries, the region becomes the desert we recognize today. The monument, by now heavily eroded, is no longer exposed to rain. Instead, it begins to be buried by wind-blown sand. The enclosure fills slowly. The figure is covered. The erosion stops. For 2,000 years, it remains hidden. Then, around 2,500 years before the present, workers under the 4th dynasty pharaoh excavate the pit. They find a weathered statue, its surface carved into channels and hollows by water that has not fallen here in millennia. The body is intact but degraded. The head, if it was ever carved in detail, is unrecognizable. The workers recarve the head into the image of the king. They smooth the chest. They add a ceremonial beard. They build 2 temples adjacent to the enclosure, using blocks quarried directly from the walls of the pit. Blocks that already bear the vertical erosion channels carved by ancient rain. They inscribe the nearby Dream Stele, attributing the excavation and restoration to the ruler. They do not claim to have built the monument. They claim to have cleared it. This sequence fits the erosion. The body shows deep vertical furrowing consistent with prolonged rainfall. The head shows far less weathering, consistent with a later recarving exposed only to wind and sand. The temples, built from blocks taken from the enclosure walls, display the same rain erosion as the walls themselves, because they are the walls repurposed. The inscriptions are genuine records of restoration, not construction. The archaeological dating is correct. The geological evidence is correct. Both are describing different phases of the same object. The timeline also fits the climate record. The African Humid Period, confirmed by lake sediments, pollen cores, and river deposits across North Africa, ended between 5,000 and 6,000 years ago. Rainfall sufficient to carve the observed erosion would have been available for several millennia before that date. The monument could have been carved as early as 9,000 years ago and still have experienced thousands of years of seasonal rain before the climate shifted and burial began. It fits the sculptural evidence as well. The head is proportionally too small for the body. Egyptologists have noted this for decades. If the monument was carved in a single effort, the proportions make no sense. But if the head was recarved from a larger, weathered original, the disproportion is explained. The workers reduced the damaged stone to a stable surface, leaving less material than the body's scale would require. The mismatch is not a design flaw. It is a restoration constraint. It even fits the textual record. No Old Kingdom inscription claims the figure was built during the 4th dynasty. The Dream Stele, erected 1,000 years later, describes the monument as ancient even then, buried and forgotten until the king ordered it cleared. The absence of a construction inscription is not evidence of a cover-up. It is evidence that the Egyptians themselves did not believe they had built it. This is not a fringe theory requiring a lost advanced civilization. It requires only that pre-dynastic cultures in a wetter climate carved large stone figures, and that later Egyptians discovered and restored them. Both propositions are archaeologically plausible. Stone carving is not a 4th dynasty invention. It is a Neolithic skill, practiced across multiple continents for thousands of years before the pyramids. The tools required, copper chisels, stone hammers, abrasive sand, were available. The labor required is substantial, but not beyond the capacity of organized pre-literate societies. We know such societies existed in the Nile Valley during the African Humid Period. We know they built stone circles, carved reliefs, and constructed ceremonial sites. We simply do not know the full extent of what they built, because most of their work has been buried, eroded, or attributed to later dynasties. The timeline is not proof, it is coherence. It allows the geological evidence to be rain erosion without requiring the 4th dynasty to have experienced a climate it did not experience. It allows the archaeological evidence to be genuine without requiring geologists to have misread stone. It allows the monument to be both ancient and dynastic depending on which part you are dating. But it requires accepting that the figure in the pit is not a single artifact, it is a palimpsest. A surface written on, erased, and written on again. And that raises a question this synthesis cannot answer. If the body is older than Egypt, what else on the plateau might be? The African Humid Period didn't fade gently. It ended fast, in some regions within a century. What happens to a civilization when the rain stops for 10,000 years? This is not a speculative question. It's a documented collapse. Between roughly 8,000 and 5,000 years ago, the monsoon belt that had drenched North Africa for millennia shifted southward. Lakes evaporated. Rivers that had carved valleys into the plateau dried to dust. Grasslands turned to sand. And the populations that had depended on that environment, the herders, the hunters, the builders who had lived there for thousands of years, either migrated or disappeared. If the monument at Giza was carved during that wetter period, then the people who made it didn't simply move on to build pyramids. They vanished before the pyramids were even conceived. And if they vanished, the question is not whether they left something behind. The question is whether we would recognize what they left. The erosion on the limestone enclosure walls is vertical. It is deep. It cuts into bedrock in channels that run perpendicular to the ground. That pattern requires prolonged rainfall, not occasional flooding, not groundwater seepage, not the brief storms that sweep across the desert every few decades. It requires a climate that no longer exists in Egypt. And that climate ended thousands of years before the first hieroglyph was carved, thousands of years before the first pharaoh ruled, thousands of years before the culture we call ancient Egypt came into being. So if the figure in the pit was carved when the rains were still falling, it was carved by people who are not in the record, people who built in stone, who understood proportion and scale, who invested labor in a monument large enough to survive millennia, and then disappeared so completely that not a single text, not a single tool, not a single settlement has been definitively linked to them. This is not a gap in the evidence, this is a discontinuity. a break in the narrative so complete that the later civilization that inherited the site may not have known who made it. Discontinuities like this are not unprecedented. Climate collapses erase cultures. The end of the African Humid Period is one of the most dramatic environmental shifts in human history. Satellite imaging and sediment cores show that the Sahara was not always a desert. It was a savanna, dotted with lakes, crossed by rivers, inhabited by hippos and crocodiles and human populations that left behind rock art, pottery and stone tools. When the monsoon rains stopped, those populations had no choice. They moved toward the Nile, toward the few remaining sources of water, or they died. The conventional narrative holds that this migration gave birth to Egyptian civilization, that the concentration of people along the Nile, forced together by environmental collapse, led to the development of agriculture, writing, and monumental architecture, that the pyramids and temples and tombs we associate with ancient Egypt emerged from the survivors of the climate shift. But what if the survivors were not the first? What if the people who gathered along the Nile after the rain stopped found something already there? The statue in the pit shows no tool marks consistent with copper or bronze chisels. The enclosure walls show erosion that cannot be explained by the climate of dynastic Egypt. The limestone bedrock beneath the monument is softer than the limestone used to repair it, suggesting that the repairs were made long after the original carving by people working with harder stone from a different quarry. These are not mysteries, they are contradictions. And contradictions in the archaeological record usually mean one of two things. Either the evidence has been misread, or the timeline is incomplete. If the timeline is incomplete, then the figure at Giza is not the beginning of Egyptian monumental architecture. It is the end of something else, the last surviving monument of a culture that did not survive the climate shift. A culture that built in stone, that carved, on a scale large enough to be seen from a distance, that invested resources in something meant to endure, and then disappeared so thoroughly that the later civilization that inherited the site had to recarve the head, repair the body, and invent a story about which king built it. This is what discontinuity looks like. Not a gap in the record, but a monument without a context. A structure so old that the people who came after it had no memory of who made it, only the physical fact of its existence. And if one monument survived, how many didn't? How many settlements were buried under the dunes when the Sahara expanded? How many stone structures were dismantled for building material by later populations who saw them as ruins, not relics? How many carvings were worn smooth by wind and sand over thousands of years, leaving no trace of the hands that shaped them? The African Humid Period lasted roughly 5,000 years. That is longer than the entire span of dynastic Egypt, longer than the time between the construction of the pyramids and the present day. Long enough for multiple generations of builders to develop techniques, refine tools, experiment with scale and form. Long enough for a civilization to rise, flourish, and leave behind monuments. And then the rain stopped. And within a few centuries, the environment that had supported that civilization was gone. The lakes dried. The rivers vanished. The grasslands turned to desert. And the people who had lived there either moved or died. The monument at Giza may be the last thing they built. The final project of a culture that knew the climate was changing, that saw the lakes shrinking and the rivers failing, and carved something into the bedrock that would survive the collapse. Or it may be one of many, and the others are still buried, waiting under the sand. The figure in the pit is not just a question about erosion. It is a question about what we lose when climates collapse, what survives, what gets buried, and whether the timeline we've constructed from the fragments that remain is complete, or just the part we can still see. The monument stands. That much is certain. The erosion is measurable. The climate record is documented. The archaeological inventory is complete. And none of it reconciles. We know the depth of the weathering channels carved into the limestone body. We know the rate at which rain erodes that particular grade of stone. We know when the monsoons retreated from the Nile Valley and when the desert replaced them. We know which tombs were built in the same quarry during the 4th dynasty, and we know they do not show the same erosion. We know the absence of inscriptions. We know the silence of the earliest texts. We know the statues that came after and the statues that came before, and the gap in the record where this one sits. What we do not know is how to make all of those facts fit into a single coherent timeline. The geologist who examined the enclosure did not speculate. He measured. He documented vertical fissuring, consistent with sustained precipitation over thousands of years. He compared it to structures built in the same material during the same proposed period and found no match. He applied the climate data and concluded that the weathering predates the conventional construction window by several millennia. His conclusion was not wild. It was narrow, specific, and grounded in the behavior of water on stone. The archaeologist who rebutted him did not ignore the erosion. He acknowledged it. He proposed alternative mechanisms: subsurface moisture, chemical weathering, localized groundwater seepage, and pointed to the total absence of any corresponding civilization that could have carved a statue of that scale before the rise of dynastic Egypt. His rebuttal was not evasive. It was cautious, evidence-bound, and grounded in the absence of any material culture that would support an earlier date. Both arguments are defending real observations. Neither is fabricated, neither is easily dismissed. This is not a case where one side is ignoring evidence and the other is revealing hidden truth. This is a case where two disciplines are looking at the same object and seeing incompatible things. The stone says one thing, the pottery says another. The rain channels suggest deep time. The tool marks suggest a known period. The weathering implies a wetter climate. The stratigraphy implies a drier one. And the longer you examine the monument, the more you realize that the problem is not a lack of evidence. The problem is that the evidence does not converge. In most disputes, time and excavation resolve the contradiction. More data narrows the uncertainty. More analysis clarifies the picture. But here, decades of additional study have not brought the two positions closer. They have sharpened the conflict. The geological case has been refined. The archaeological objections have been reinforced. The gap has not closed. So we are left with a choice that is not really a choice at all. We can accept the erosion as definitive and conclude that something resembling civilization existed in the Nile Valley thousands of years before we have any other evidence of it. No cities, no tools, no graves, no writing, no ceramics, no architecture, just one statue in a pit. Or we can accept the archaeological record as complete and conclude that the weathering, however strange, must have some explanation that does not require rewriting the timeline, even if that explanation has not yet been demonstrated in a controlled setting. Neither position is comfortable, neither is intellectually cheap. The first requires us to believe in a phantom culture that left behind a single colossal monument and then vanished without a trace, leaving no settlement, no secondary works, no continuity into the later periods. The second requires us to believe that the most visually obvious feature of the monument, the deep, rain-carved erosion that differentiates it from every other structure on the plateau, is somehow an illusion, a coincidence, or a product of processes we have not yet identified. Both are asking for a suspension of something we thought we understood. And that is the real lesson of the monument. Not that ancient Egypt is older than we thought. Not that a lost civilization built the statue and disappeared. But that a single object, examined carefully, can generate a conflict that resists resolution even when all the facts are known. The evidence does not lead to certainty. It leads to a choice between two uncomfortable conclusions, neither of which fits cleanly into the framework we inherited. This is not a failure of science. This is science working exactly as it should. The geologist is not wrong to measure erosion and follow it to its logical conclusion. The archaeologist is not wrong to demand material culture before accepting a revised timeline. Both are doing their jobs, both are applying rigor. The fact that their conclusions do not align is not proof that one of them is corrupt or blind. It is proof that the monument is genuinely strange. And strangeness, when it is specific and measurable, is more valuable than consensus. Because consensus can be wrong. Consensus has been wrong before. The timeline of human history has been revised repeatedly, not because fringe theorists shouted loudly enough, but because new evidence forced the revision. Göbekli Tepe was not supposed to exist. Derinkuyu was not supposed to be that old. The domestication of wheat was not supposed to predate settled agriculture. But the evidence arrived and the timeline shifted. The monument in the pit has not yet forced that shift, but it has created the conditions under which a shift becomes possible. It has introduced a legitimate question into a field that thought the question was settled. And as long as that question remains open, the monument remains more than a relic. It remains a test. The stone is a witness that contradicts the written record, and as long as that contradiction stands, the figure in the pit remains a question carved in limestone, older than the answers we've been given.